All right, we're recording, and we're going to review for the exam today. Maybe a little bit next time. We'll see how far we get today, okay? So, where are we going? What are we doing? Right now, we're going to go to Newton Alta Assignments, and then I'm going to click on this Test Review Center. Now, I have to do it as a student to be able to make it work, but you guys are students, so it will work. Yay. Here we go. So, Newton Alta Assignments, coursework, Test Review Center. And like y'all can pull this up too at any time. This is what I recommend to start doing, like practice quizzes and all that kind of stuff. So I'm going to review this. I mean, you can like click somewhere else. I think review is the only thing I really want. So we're going to review the exam, and I have to say, on your exam, this is the list of questions on your exam. Okay, if it's not here, well, then you got to keep clicking because eventually you'll see it. So definitely the topics are here. Everything's here. So we're going to go through it one by one. Now notice like I click on 1.1 and at the bottom they have individual objectives. So that basically means that from 1.1 we have 2 questions on our exam. Okay, you'll get this one, you'll get that one. Cool. And again, it's kind of spread out. You're going to get this randomly and that randomly, and it might not be exactly the same, but I mean it will be that topic. So I'm going to do start review. And let's just go through it. And again, some of these are going to be easier than others. A lot of this early stuff, I can't remember definitions. So you're writing down definitions. You know what I mean? Okay, cool. Because, like, I don't remember. Data is a subset of the population studied. What? I'm going to guess. A lot of these I'm going to have to guess on because I don't really know. And that's why it's okay. It's practice. We're practicing. We're reviewing. That's all it is. And now I probably ought to know what the subset of a populated study is, and I should probably also know what data is. Okay? So I'm going to say false because I think that means sample. That's my guess. Okay, I'm going to say sample, and okay, right there, sample. There it is. I was right. Thank you. Thank you. I got one right. So let's keep going. We're going to keep going through this. Study the mean number of siblings and for each student in her school. She records the number of siblings for each of 200 randomly selected. What's the data? What do y'all think? Like the raw data. I'm going to guess specific number of siblings. It's like, how many do you have? I got 1, I got 5, I got whatever. There we go. So the data is the specific raw data values, I guess you can say. Not the computed stuff, not mean. It's not the people. It's just how many they got. Cool? Okay, easy enough. Y'all saw how I got 1 out of 2 review things complete? Like, that was great. I'll show you if we want more, we can get more out of this. In reference to different sampling methods, cluster sampling, see, that's something I should probably write down, right? What's cluster? Is use a random sample, select from groups every individual from a chosen group. Does that sound right to you? I like it. I'm going to say true. Yay. Again, yeah, that's what cluster is. So you can put in your own words. You can literally copy this down if you want. I mean, it's just a definition. It's whatever you want there. In order to study the mean pulse rate, studied the population by dividing residents into regions, randomly select 12 regions from all the people in those regions. So he's breaking it up into different places, physical locations, and then he's going to everybody from there. What would it be? Literally just saw this. I'm thinking cluster again. But you know what's going on here? You should definitely know all 4 of these for sure. You get me? Write these down. If you don't know them, like by heart, definitely at least put something down or maybe like a little English sentence. This is the stuff that I don't remember. This is the stuff that you need to put down on note cards for sure. Is that cool? Okay, now we're done, right? We're going to click it says, yeah, you're done. Awesome. Hey, I felt pretty good about that. Okay, well, I just don't care. Now, it's changed. You see how it says practice? And so we can actually go back and do it again. If we want to sit here all day long to see the different questions possible, you can, and that is fine. So it wants to estimate the number of cloth diapers, blah, 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 blah. We got a group of 200, whether or not, what's the data? specific yes nos. And so, I mean, I could sit here literally at this point all day long going through these until I'm just blue in the face. Okay? Does that make sense? I'm not going to do that, but you can. More instruction, all the same stuff is all here for you. Okay? I'm going to get out of that. We're done. You can even click on this stuff. You can go look at stuff. I don't know. Just there you go. Moving on. 1.2. And notice I only got the one objective. So again, one question from 1.2, and it'll be something about measurements, level of measurements. So that's going to be nominal, interval, ratio, ordinal. One of them. There we go, those guys. So the market researcher finds the several brands of fabric softener. What's the level of measurement? Price of several. What's price? Is it mathy or not mathy? It's mathy, so it's one of these guys. Is zero the very least it could ever be? Zero is like nothing, basically. Zero price is free. Ratio. Could it be negative? Can they pay you to take it? Please take my fabric softener. I'll pay you. I mean, I guess, but we're going to click ratio. That's what makes sense. Again, you can write this down. Ratio data is the price for true zero. Whatever you want to do. Okay? Cool. What you can't do are examples. So specific examples in statistics would be blah, 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 dollars of fabric softener, or interval would be like years and all those other little examples we did, right? AM, PM, and all that stuff. Can't put that stuff. But what you can put is can be negative. You put some English like remember this and put it in some kind of cryptic thing that I don't know. You do a language that I don't understand, it'll be fine. No one understands you. You get me? Okay, cool. Okay, cool. Continue. Mother tracks time, baby wakes up. So we're talking time. And I guess this is like AM, PM. What would you think? Yeah, interval. That's what I'm thinking too. Yep. And so blah, blah, blah. I don't know what they're talking about, but again, AM, PM, negative, positive, that kind of thing. Cool. And we're done. I mean, it's just that easy, but you can sit through this all day long if you want to. Your call. Okay? I'm not going to. Definitions are one thing. We're going to move on. Oh, there's another one. Look. So this is 1.21, I guess. So now you have two questions from this. Natural variation found in selecting a sample, larger population. Oh, yeah. I think this is a sampling error. Is this one of those? See, all these definitions, man. Oh, yeah, I remember. So, I mean, perfect example again, right? Just write down some of this stuff. Biased. Oh, man, I remember these guys. What's the estimated mean number? She collects data from this. Individuals from cafeteria. Oh, yeah. Consume calories. Breakfast? That's bias, yeah. And so it says water bias, so we're going to click it. To estimate the ethnic background, collects 1,000 randomly selected residents. Random number? Yeah, I don't think so. Yeah, good. So estimate the mean number of money spent by mall shoppers. He's right outside the mall. So I think that's bias because you're like right outside the mall. Wants to estimate the grade mean point average every 25th student. I think that's fine. And again, we're just reviewing, so I can just click it and hope for the best right now. Cool. Good. Collecting samples, 600 students. University, whether or not they exercise more than whatever. 53 in the nation. Oh, there we go. More than this. Why is it misleading? Pretty interesting. Why would this be misleading? They say it is. We're going right outside the university, and she's saying now it's for the nation. Can I say something here? I'll do this while being recorded. People in college, we look pretty good. We work out. Ooh, yeah. We're in our youth. But see, in the nation, I mean, once you get out there into the workplace, oh man, everything just goes to heck, man. I'm so sorry. So what would you put? I'm gonna think outlier. Do y'all agree with me? Yeah, because like this university would not represent everything in America, let's say. Oh no! Why is it biased? Okay, hold on. Individuals included the sample are not. That's what I was saying. Okay, so this is a perfect example of individuals included in this are not representative. That's apparently biased, not outlier. I don't know. Yeah. You fight me for it if I don't already give it to you. Yes, exactly. I'm recorded on that. Because I mean, yeah, it's words that I even get wrong. I'm proving to right now that I don't even know some of the stuff. So yes, I'm going to be very liberal in grading this kind of thing. Yeah, I can't just give free points, but I can definitely try. You know, if you kind of argue your case and et cetera, et cetera, et cetera. Thank you. So average fee to start up is this. Oh, yeah. This one I know for sure. Notice that the 74 is not really part of these guys at all. That's the outlier part. Yep, there it is. There it is. You're right. It's for a group. Yes, that makes so much sense. You're right. Bias is for a group. Outlier is like one value there. You're right. You're right. Same thing here, right? So that would be outlier again. Once you roll through these enough, you'll see enough of them that you're like, I got this, We're almost done. So whether or not they attend church, and so that was in the town, and now he's doing for the state. So again, I wanted to say that his little thing is outlier, but it's bias, right? It's for a group. Now we know. Okay, cool. Got it. That's perfect stuff to write down on your note card. Yay, cool. Are y'all good with this? Okay, I think that's the end of the chapter 1 stuff, which is good. Yeah, I think that was it. Whew. All right. So as we move on to chapter 2 and 3, and for the rest of the class, have y'all been really using a lot of this chapter 1 definitions on your homework? Yeah, like right now. Exactly. Y'all didn't think that back on the first day. You're like, Chad, this is important. No. It's just you gotta test it and move on. Oh. All right, histograms. Here we go. Oh yeah. So we're just sliding these things around. Like what I do, and whenever I'm looking at these things, I always scroll to the bottom to see is there something else they're wanting, because sometimes they'll have this kind of stuff, and then they'll ask a question below it, and that this wasn't really meaningful. So just kind of watch out for those things. So I'm supposed to slide these things around. I think they're wanting to use the lowers. Is that what they're saying? The first of the lower class limit. So if y'all have done this at all, you know what's going on here, right? So 16.9, 18.4. Is this boring yet? Yes, Chad. And then we got 2712. 2, 7, 1, 2. There we go. That was it. Yeah. Is that okay? No? I just chose these numbers because it said lower. So I just chose those for the bottom. I literally just slid them over to the right places. And then I just did the heights. That was all. Yeah, it's actually kind of like, but blah, 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 lots of math that we didn't use. These guys. The upper O, and then we got 1.1. So it's like on the 1 decimal dealy. If I had a 0.5, then this would be a what? 0.6. So we got that much. Yeah, 2.0. And it looks like it's going to be 1.5 here, just kind of looking around, right? So 1.6. And this guy? 0.1. Yeah, that's my guess too. 0.1. Look at it. So we're looking for things from 1 to 5. So that's going to be 1, 2, 3, 4, 5, 6. 6 numbers in there. 1.1 to 1.5. Just 2. Just the 2. And then anything 2.1 and onward. I got one of them. Yeah. I'm just looking at them. Yeah. Kind of decoding. Okay. Is that okay? Yeah. Okay. Yay. Decoding. Burp, 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 burp. Oh, second part. So I think they're always wanting to use a lower. See, it says like use a lower class limit. So we're just using these guys. So 0.1, 0.6, 1.1, 1.6. Dun, 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 dun. There we go. And then I look at how many we have. 6, 4, 2, 0, 1. 6, 4, 2, 0, 1. There we go. Just using these numbers, using those numbers. Go ahead. Oh, they did the last one for me? I know, right? Well, I yelled at them for this, and they fixed it a little. They used to actually have a solid there, and you could move it, but obviously you can still move it. It just doesn't look like it. As of now, I think they should not have you mess with that. I think. I yelled at them for it. You can see that, like, it still kind of does it, but still kind of doesn't, you know? So it's kind of weird. Something just attacked my face. Okay, y'all didn't see that. We're good. Okay. Oh. Shows a certain technique to save this much and at least that much. How much blood if it saved new technique? I think they're just saying from this to that, so it would be the 0.5 to 1.1. No. At least, okay, I'm just rereading it here. So it saves half a liter of blood that have lost at least this much. And so that would be the 1.1 and onwards, right? So that would be 3 people. 3 people times 0.5 is 1.5. So half a liter each. I don't know. We're just reviewing. Okay, cool. So yeah, they're saying at least 1.1. So that's going to be all these folks and downward. Yeah. So it'd be 3 people in that group, right? And then they said for each of them 3 people, we got half a liter. We did it! Confetti! And again, we can keep going. If y'all want me to keep going, seeing more. No? Oh, go through all of them, then we can come back. Yeah, definitely. Definitely. I'm all about that. Yeah, find the mean. I might get GeoGebra up here in a second. Oh yeah, this is GeoGebra for sure. So before you even get started, I recommend having it up. You know, that way you're not like fumbling and stuff and taking time. Like, can you help me get to GeoGebra? And they're helping with somebody else for a minute, so they can't come for 5 minutes, and then they forget about you entirely. And no, just like get it up all ahead of time. Just that you're ready. That's my recommendation. Okay. Now, can I copy that? That would be super awesome, wouldn't it? No. That didn't work. I wouldn't sit here trying to like goof with it too much. If you know how to copy it, cool. If not, just roll with it, man. You know, I do have to say, be very careful. Sometimes they'll slip an extra number in there, and it's happened to me. Like they'll do 8, 9, 10, 11, 12, 13, 15. And I know, right? And they'll do that. And I've seen it. It's so frustrating. So I put it all in, highlight one variable analysis, sigma x, done this a bazillion times. The mean is 10. We can move on with our lives. Yeah. Yeah, let's redo it. Yeah, from the very beginning. Oh, wait. Can I erase it? I'll erase it. So I'm going to type it back in, right? Yes, I could definitely do that. No problem. Cool with that? Oh, you see this 8? You see how it's all messed up? This happens. Like if it doesn't calculate correctly, I think you just got to keep hitting delete or backspace or something, and like eventually, if you hit enter on it again, okay. So just watch out for those little things. I've had it not work just because of one silly little thing like that. Okay. Okay, cool. So yeah, they're all in. Good with that? I'm gonna click and highlight, click, drag, highlight. I just want to select them all. And then up here, oh, sometimes it shows me. Let me see if I can click it again. One variable analysis. We just click it a lot of times. And then this little Sigma X thingy, little EX looking thing, and then bloop, it's already up there. I don't know what that thing is. Forget about that thing. Go away. Go away. Go away. Anyways, our number's 10. So cool. Is that cool? Good now? Cool. We're going to do it like 100 million times here. Find the mean. Perfect. So if I go back in here and I put 0-3, I mean, oh, that looks great. But no, if you notice, it's on the wrong side. And when I put the other ones in, you see it's all gacked up. I can say that, right? So we can't put that in there. We have to put what is in there. We need to put the midpoint. So yeah, 0, 1, 2, 3, and so that's in the middle would be 1.5, right? So I'm going to put 1.5. Okay, and then 4, 5, 6, 7. So that would be 5.5. It's in the middle. 9.5. 10, 9. Select one variable analysis. Click this guy. The mean is 5.23. Spider webs. Yay. Is that okay? Cool. Any questions on this? Okay, you talk to me though. I'm here for you. I can read. Oh, hey, look at that! Yay! All right, let's see what else we got. Skewedness. Oh, there's 3 questions from this section. All right. Oh, okay, perfect. So this is another GeoGebra problem. So 14, 10, 9, 7, 10. Again, you see the problem though, right? Every time. Watch out for that, okay? So I need to find the variance, but to do that, I need to go and do the same thing. And they don't give me variance. I need to find the standard deviation and square it. So this is where you also should have like a Desmos or something up, or you can use a hand calculator. It really, whatever is best for you. I need to take my, hold up, sample variance. Now, sample is the Latin characters. And so that would be my little s, the 2.54. I need to square it. So 2.5495, and I'm going to square it. And so that's my actual answer. Okay, so I took that number and I squared it. And you can use GeoGebra again. It's up to you. So that's something that you can write down on your note card. Oh, it says 1 decimal place, 6.5. There we go. So that's something you can write down on your note card. Variance is going to be the square, standard deviation squared. Okay. Also, sample uses Latin characters. Okay. So sample would be little s. Population would be that sigma thing. See, there's like a little sigma. That's a little tiny sigma. That's a small sigma. I should probably differentiate for Greek here. That's a capital sigma. This is a lowercase sigma. I know, right? Like you got capital A and you got little a kind of thing. Something like that. Yeah. Sample is Latin characters. So Latin characters are like English characters, things that we normally see. Sample will use like X, bar, S. I think that's really the only ones that we see here. For a population, it uses Greek characters. So that would be like the mu's and the sigmas and anything that looks weird. That would be population. For the variance, variance is the square of the standard deviation. Yep. And that's definitely a good formula to write down. So the variance is equal to the standard deviation, and then you're just squaring it. Yep. Yep. Cool. Because it doesn't give that to you here in GeoGebra. But we can just do a little square action. We're done. And you can use a pocket calculator for that. Super easy. Cool. And notice like what they're wanting to do here. Look at all this. They say, do it by hand, do it by hand, do it by hand. Like, you know what I mean? We don't want that. We don't want that. Okay, look, sample standard deviation. Correct. That's right. And look, it's the same numbers. So I'm going to go use the S number here, 2.54. This is 1 decimal. There we go. That was easy. I have to say, I have seen this before. Very frustrating. Very frustrating. So just watch out for that kind of stuff, okay? That will happen in this class again, okay? They do that. All right. Z-scores. So yeah, we need a formula for that. I'm just wanting a little bit of stuff up here. So Z is equal to the value minus the mean divided by the standard deviation. Like that's your formula, I guess you can say. Value minus mean divided by the standard deviation. And so I think that I need something to write on up here. You know what? I have a good idea. This is what I'm going to do. I'm going to pull up a blank piece of paper. Okay, so yeah, let me draw on this. So Z is equal to the value minus the mean divided by the standard deviation. Okay, so I'm looking around, and they say average monthly has increased from this to that. He's curious about what's going on. And if you've done this problem at all, you're just doing the same thing you did earlier on the homework. So 83 minus 85 all over 3.20, and you'll get a number. And the other guy is going to be 102 minus 105 all over 4.00. I'm going to use a calculator for those. Where's my, oh, here we go. Okay, cool. Y'all good right now? Okay, awesome. I'm going to write those down. Then we'll just put those in and answer whatever they got there, that kind of thing. Good with the calculator? Again, you could use whatever you need to use. I'm just kind of showing you what's going on here. Okay, so let me put it in. Negative 0.6, 3 decimals, 25. Okay, and then we got negative 0.75. Yay. Cool. It says which one's higher, respectively. Notice that this one here is actually higher because we're talking negative numbers here. So like we got negative 0.75, and then went over here we got negative 0.625. So that one's technically the one that's higher. I know that's really weird. So Illinois. Okay, awesome. Okay, cool. And this is the most exciting thing ever. Yay! I come to class to get excited. I don't know, guys. I'm sorry. I'm just trying. Which has the largest standard deviation? Which has the most spread outness? Right, this most spread. Does that have a lot of spread? What about this guy? A little bit more. Does it got more spread? More spread? Right, the most spread. And you can write that down. I mean, that's not an example. You could say standard deviation is equal to the spread. There. Those would be examples. Yeah, like for my algebra class, they have the end behavior, which does all the different things, and I told them I can't because I was told I can't let them do that. I don't know if y'all had algebra. These are pretty cool, but they don't. Yeah. You can write on a chart. It would look like this, and with that, and blah blah blah. I mean, English would be fine. On a chart, it would be more spread out, and if it's bigger in a da da da, I don't know. Whatever works for you, as long as it's not specific things. Smallest. So that's pretty spread out. Ooh, that's very spread out. Ooh. Right, not spread out at all. That one's good. I like this guy right there. Smallest spread. Cool. It opens now. Yeah, you can come. You can go take it right now. Down to the advanced math lab. Yep. I should have probably said that. Let's pause for a second. So yeah, you go down. Testing, and you're like, I'm here to take a test. So try to make it funny. And so they, get you on a computer, you log in the Blackboard, and you click on the exam, and then they put the password in, and you're good to go. Bring your note card. They'll look at it and say, cool. Do scrap paper. It's cool for scrap paper. Scrap paper is awesome. Put your name on it, my name on it, and I'll look it over, that kind of thing. I have to say, though, I've had some people in statistics write the entire question down on their scrap paper. That's a waste of time because I can see what question you have. Okay, I'm not kidding you. They would write this at the very top. They would say, which of the data sets represented blah, blah, blah. And it's such nice handwriting. And I'm like, wow, you probably spent 2 minutes writing down the question when you need to be doing the math. Oh, so I can see what you've done. You write down whatever you need to. Yeah. No Scantrons. Yeah. Scrap paper is fine with me. Oh no, they'll take it from you. Oh yeah, they'll take it out of your hand. You don't have to write down. Yeah, you don't have to. It's better to just in case. I have had, and not here in Newton, but I have had in my calculus classes where it blacked out the rest of the test, or it like didn't submit all their answers. And yeah, I was thankful when they had written it down. Like just write down a quick jot. Like here, you would just like write down question 5, C, next question, just in case. But it's never happened in statistics, thankfully. I just maybe I'm overcautious. Well, if it does, there's this X button at the top, and then you get your car keys and you go home, and then I'll fix it later. Yeah, okay. Well, I'll fix anything, I'm totally okay with fixing problems. No one's gonna fail because of a computer issue. But the more safety, the better. All right. So like if it's burdening though, then just don't do it. Like here, just pause for a second. How many things have I written down on my scrap paper? Right? I wrote down one thing maybe so far. That's okay. I mean, some of these things there's not really much to talk about. If you want to write more. Okay, 5-number summary. Interquartile range. I don't know if you remember that one. Interquartile range is Q3 minus Q1. Again, that's like a formula. Might as well have it, So then that's going to be 81 minus 68. What is that going to be? 13? 13? 13. Look at that. Yay. Cool. I bet this is the one that's going to change. Oh, yeah. Oh, yeah. Oh, man, how frustrating. You see it right here, look. 67, 68, 80, blah, blah, blah. Totally different numbers. And some of them are the same, which totally makes you think, oh, it's the same numbers. I got 80 again, so we're good to go. No. Totally different numbers, totally different math, okay? So watch out. Interquartile range, which are the following are outliers. So let's try this out. What I have to do is start over. So first off, let me erase all this stuff. Let me do eraser. Erase, erase. Eerie. I know, you're thinking, well, surely there's a way for you to erase the whole thing at once, Chad. I wish. Okay, that'll be enough. There we go. Okay, so I need to find the IQR first. And so that's going to be the 86 minus the 56 is 30. And then I'm going to go 1.5 times that 30. And I'm going to subtract the, no. I think I start with the other one first. Let's just find this 1.5 thing. So 1.5 times 30, is that 45? I think it's 45. So that's the distance that we're going to be using for all this stuff. So it's Q1 minus the 1.5 times IQR. And yes, yep, exactly. And then Q3 plus the 1.5 times IQR. So these are the two formulas. So essentially I got 56 minus 45, and then I have here 86 plus the 45. Yes, always 1.5 for sure. Inner quartile range, and then we're multiplying it by 1.5 for like a distance. Yeah, I like that distance. That's a good one. And so that distance that we're changing from Q1 to Q3, that thing right there. Correct. Yes, it's going to give me the lowest and the highest, and everything outside of that is an outlier. So 56 minus the 45, is that 11? I think it's 11. And then this guy, 86 plus that is 120, 131. So it's anything between these is fine. Anything outside is no good. Right? Is there anything else that would fall outside of that zone? Let's try it. Cool. Now, could you, I know, right? I know it's weird to me too. Weird but true. Yep. Could you look at the data and probably just make a good guess? Probably, but I'm just overcautious again right now. So cool. We good with that? I know that's a little bit weird formula, but that's why we got formula cards and stuff. Okay. Let's keep cruising. What else we got? See, they're doing it too. 1.5 times our QR, plus and minus Q3. It's just what they do. Okay. Oh, we did it! Yay! We can come back. Later. Whoa. Are we in chapter 3? We're in chapter 3. Look at that. Okay, cool. Okay, chapter 3. Let's check it out. Oh man, these are fun. So we were talking about this after class last time. If you want to have just like a set of formulas that always works, you can list out all these individually. So the or, I'm going to do the succinct version. Here we go. We got right now or is equal to A plus B minus the and. But if you manipulate it, you can get whatever you need. So like the and the or can swap. So and is equal to A plus B minus or. So that's another option. If you want to get like A by itself, you would move everything else to the other side. And so A would equal the and plus the or minus the B. And the same thing with B, it would be the and plus the or minus the A. I believe that's all good. And we can find that right now. We can just test it right now. So B is what we want. And so then I have and is 0.1, 0.01. My or is the 0.89, and I'm subtracting the 0.4 from it. So basically, I think I got like 90 minus 40 is 50. Let's check it out. Cool. Yep. So if you're like a formulas, those are great formulas. If you like algebra, you've been through algebra before, you like that stuff, do whatever you want. Cool. Good. Good. Yeah. Okay. Cool. Let's see what else we got here. Another one. Yay. So I want this one. So I got my 0.5. I got a 0.3, and then I'm minusing the 67. So basically I got 80 minus 67. Is it 13? Y'all are confirming with me, right? Yes, Chad. Good. Yay. Cool. Say that again. Complement and addition rule. Addition rule would be the main thing there. They won't give you topics like that though on the test. They'll just like do the whole thing. Yeah. So it's hard. I say we shouldn't rely on topic. I guess more just like what does it look like. No, it's in order. Yep, and it's in I think the same order as this. So yes. No. No. No, it used to be scrambled, and then we got rid of that. If it is scrambled, there is that X button at the top, and then you can come complain to me, okay? Because I said not. We used to have it like that, and it's not like that anymore. I've been told that many times, okay? We got rid of that feature, that bug. So what's is not a multiple of 7? So multiples of 7. Let's start with 7. 7, what else? 14, and then 21, 28, 30, 35, 42, 49, and that's it because we stop at the 50, right? So these are the numbers we're supposed to not have, okay? So basically 1 through 50 is 50 different numbers, but then we have 1, 2, 3, 4, 5, 6, 7 that we're avoiding, right? So like 50 numbers minus the 7 that we're avoiding is 43. So far so good. But it says blah 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 about a fraction, and they're talking about probability, so it's over a total. It's 43 over the total of 50 possible. I don't think that those reduce at all. Let's see it. Yeah, there you go. Cool. So you list them out. And you say, okay, cool. We should avoid these numbers. So I say 50 total minus those 7 that we shouldn't have is 43 actually. Let's start erasing up here. It should be 20. 20. I'm going to say 20. Not just should, it's 20. I'm going to have to, okay, I'm going to say should. Because, yeah, I mean, yeah. Yeah, I probably could. Not a multiple of 6. It's the same as last time, right? So we got 6, 12, 18, 24, 30, 36, and we should stop because it's 40 there. So that's 6 of them. So we got 40 minus the 6 is 34, and then we're going to divide that by the 40. You can reduce that down, but I would recommend using a calculator for that. So 34 divided by the 40, 17 out of 20. Like anytime there's something like simple math that you're like, I might be able to figure that out, don't. Just let the calculator do it for you. Right? Much better in the end. Awesome. Cool. We got time. We got this. Conditional probabilities. Let's see what this is. Full-time, part-time. Oh, okay. This is when you're drawing on the screen. I wonder, did they let me draw on this screen? That would be awesome. Okay, fine. So, according to the table, what's the probability a randomly chosen student does not own a car given that they are part-time? You see that given? So I'm saying only part-time. Only part-time. So then I'm covering up the full-time. My total doesn't make sense anymore. I'm only looking at the part-time column. Now that I'm looking only at the part-time column, they're saying what's the probability does not own a car. So how many do not own a car? Out of? There it is. You got it. 7 out of 29. You got it. Yeah, 7 out of the 29. I don't think that reduces. Okay, cool. Awesome. Good to go? Awesome. I'm just getting some of this stuff out the way here. Is there a way to make this bigger? Erase. I mean, I can make this bigger. Does that make my eraser bigger? No. But it makes this bigger. Okay. Okay. 150 total. So what's the probability a randomly chosen student prefers calling given that they're male? So we're only looking at the males. Probability of calling is 8 out of 30. See you later. Thank you. Let me reduce my thickness down a little bit. So 8 out of the 30. I think that reduces. So 8 out of 30 would be 4 out of 15. Awesome. Bloop. Cool. We got time. We got this. We did it! Confetti! Woo! I know, right? That's what I was thinking too. Yay! It's like a little wave. Like a lot of these just have the one question. So let's see what we got. Probability of major and statistics course. See the word "and" right there. Statistics course given is this much. What's the probability of business major? Okay, so what I'm gonna have to do is, here, let me real quick get some more room. Y'all okay with a few dots in the way? No, okay, I'll erase it. I'm so sorry. I'm trying, okay? A little random 4 over there. Even that little dot. Okay, good. So it says, what's the probability of business and statistics? Okay. Now there's a formula for this. It's the probability of business times the probability of statistics given business, or it's the probability of statistics, probability of business given statistics. So these are just the two different formulas, I guess you can say. And is equal to B. You know what? I don't like writing it like that. I actually want it the full length. Okay, give me a second. Probability of A and B. There I go again. Give me 1 second. Hold on. A and B is equal to the probability of A times the probability of B given A. That's the official formula for this. And you could switch around your A and B and it'll be fine. So the probability of and is 0.29. 0.29 equals the probability that we have statistics given business is the 0.67. So they're saying what goes in this box here. So I'm just following the same format. And equals probability times given. How would I get this to the other side? Divide. Ugh. Very minimal, at least. Calculator. Let's just see if this is it. I'm a little bit skeptical, honestly. 0.4328. Let's just see what that works. 3 decimals. 433 rounded. Cool. So how are they doing it? Oh, they just say these are your two formulas. Okay, well, there you go. Cool. Kind of of thing. That's what I recommend, is kind of like using the letters. We were doing that earlier before class with the less than and the odd, even, that kind of stuff. So yeah, letters are. Let's see if we got another one. Yep. Okay, so yeah, let me get a little bit of room for this. You know what? I wonder, if you don't mind, I think I'm gonna just open up another one and just like, no, not that one. Yes, this guy. Look, now we got yeah, we got 2 pages now. Yay, guys, 2 pages. Whatever. So probability of unvaccinated and visits the emergency room is 10%. So let me write up my style. We got and is equal to probability and then times the given. And so the and for me is the 0.10. Says the probability given, see the word given? Like, I don't want to do normal probability. Like when I see the word given, that's the key word there in that case, is 0.57. And so then they're wanting this guy again. Divide. There we go. 0.10, 0.57, 3. Let's put this in. 175, 3 decimals. Okay. I'm going to definitely pause on this here. It's not that I had 2 questions that were very similar. It's that this was on the review center at all. So this one's a little bit more intense than, I mean, guys, we work for the workbook, right? Whatever's on the workbook, we do. But I didn't remember seeing a lot of this on the workbook. Are y'all okay with what I'm doing? Is this okay? Is this okay? Yes. Very good. Very good. The only thing that I find confusing about my formula is that it says right here the probability blah 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 blah. So I think that's the thing that I'm looking for. That's a little weird about my formula. I don't know what else to call it though. Yeah, go ahead. Please do. Yeah. Yes. Yeah, if you like that, that's cool too. Yep. Good. It's all those algebra skills you got, right? Oh, okay. Cool. Let's keep cruising. Mutually exclusive. Were we talking about this earlier? An event of a patient at a doctor's office, flu, and a patient being a woman are independent. Okay, so they say that ahead of time. What's the probability of flu and woman? So, okay, let's just pause for a second here. They got the 2 numbers, and they're wanting the and, right? The keyword is and right there. And means to multiply. Yeah. And then you can write this down. And is multiply, or means add. Generally. Again, generally. It's not perfect, but that's what I would generally start with, right? They give me 2 numbers and not anything else. And I'm supposed to use this formula, and I'm going to write it down again, but this is not really what's going to happen. It's the A plus the B minus the OR. And that's basically, they're saying, what's the and, right? They're saying, what's the probability of and? But we don't have an or. Does that make sense? We don't even have an or. And it said right here, independent. So that basically means this or thing doesn't work. We just messed up. I mean, this is a great formula, not really. Let's erase it right quick. I'm so sorry. I'm so sorry. Let's start over. And means to multiply, guys. So what am I doing with these 2 numbers? I feel so stupid. So, hey, do I mess up? Do I make mistakes? Come on, go ahead and say it. Mixed opinions. I make mistakes too. And that's why we're writing this stuff down, or at least kind of getting a feeling for what's going on here. if I were to turn in my work and I saw that I had a plus right there, at least I would look, or you could argue with me and say, like, bro, you turn it sideways and then it's fine. Right? I mean, when you're writing a couple things down like that, at least there's a good way to talk about it. Anyway, so I'm multiplying, I got the 5. But I can't put 0, 5, 8, 5. That's not what they want here. What do they want? Yep, 5 point. All that stuff, right? Move it over by 2 decimals. Yeah. Let's check it. Yeah, and means multiply. Just keep it simple. I don't know what I was thinking. Just and means multiply. Okay. And means multiply. Blah, blah, blah. Independent. Blah, blah, blah. And. So I'm going to multiply. Here we go. So 16 times the 14. And means multiply. 0.0224. Do you see what's going on here? 3 decimals. Okay. Notice that this time they didn't want the percentage. I know, right? Man. So they're trying to get us on these tiny things. If you put 2.2 and the answer is 0.22, I totally understand what you did, and it's okay. That's the exact thing that I'm looking for to add points about, okay? Like 100% on that. That's just a decimal place. Okay. Certain company, we got outreach, probability of accessing this. What's the probability of this or that? See the word or now? And or means to add. I'm going to try it again. There's just 2 numbers, so it shouldn't be too bad. I'm going to add them and see what happens. This is why we're practicing. We're practicing these things to see, like, hey, what am I doing on these problems? When it says or, I add. When I multiply, and means multiply. There we go. See, and they're trying to go all crazy with all these formulas and stuff, but just, yeah, it's whatever. Certain company, HR benefits, this and that, probability of this, probability of that, probability of or. There it is, keyword or. Okay. Or means add. There I go again. 80, 87, 87, 87. Cool. 87. Sweet. Got it. We got 2 left. Oh man, I can't stand the last one at least though. We're not there yet. That's a good thing. So suppose that we have 100 unique names and without replacement. Okay. How many different ways can you draw all the names in the hat? Oh my gosh. I'm just going to be straight with you. It's a huge number. And you just have to put the factorial. Notice right here it says in factorial notation. It's saying you got to use the little explanation. And it's really that easy. It really is. So it's more just understanding what we're supposed to be putting in the box. Okay? It's no math here. At least yet. Let's see another one. Look, factorial notation, 70. I didn't even read the problem. There you go. It's knowing what to do where, you know? It says factorial, give me one number. I don't know what else to do. It has to be this way. We're not here to learn. We're here to test. We're here to get points, right? I'm not here to make the long explanation. I'm here to, pass and move on kind of thing. And that was it. I almost want to keep going. Just another. I want to see if there's another one like this. Okay, see, whole different problem, right? And that's okay. It's just we have to, that's why we go back through these guys a few times. We got 4 students all taking a math test. 4 tutors are available. Each tutor is available to help on 3 subjects. How many different ways? So tutors, students, and subjects. So we got 4 students, 4 tutors, 3 subjects. What is this, 16 times 3? 48? Cool. I can go all day long. Look, 15 factorial. I just want to do like one or two more just to kind of make sure. Oh, we're like near the end. Okay. Wait, but this is a whole different problem. So this is good. How many different ways to receive advertising in the mail? 2, 3, 2, 2. Is that what that would be? 2, 3, 2, and 2. That's a funky 2. Am I right there? Week 1 we get something, and then in week 2 we get something, and then in week 3 we get something, and then yeah. Good question. It's implied, yeah. It's implied. So we got 6 times 2 is 12 times 2 is 24. Let's just see. And again, we're running through these because these are the questions that'll be there. So I'm just practicing, you know. If I get it wrong, I get it wrong. But at least now I can kind of see. Cool. I want to do the last one. Okay, we saw this one. That was on the workbook, I think. Okay. Last topic, because we're like really close to the end here. Okay. Oh man. It's the worst ever. So I am super liberal when it comes to grading this stuff, okay? I'm not expecting perfection because I cannot do perfection, okay? I'm going to try my hardest here with you, but in the end, we're going to do what we do. So I'm going to think it's doctors from the first hospital, doctors from the second. Total doctors from the first, 20. Total doctors from the second. Total doctors, 50. Total. Okay, now presenting doctors from the first, 8. Selected doctors from the second. And then totally selected doctors, 15. Okay. Cool. So like we've done this one before. We've done this like so many times. It's ridiculous. But there's going to be one that I totally haven't seen before, no matter how many times I run through this stuff. Ugh. Oh, and then they want us to actually find it. So yay, part B. So NCR, you're already packing up? Is it time to go? Yes, Chad, it is. Let me just do the last problem here. 11.39. Awesome. Okay. That was it? Nah, I know you want to leave, bro. Okay, see, totally different problem, but not. It is actually not too much different. So I think this is red, not red. So all 3 red. So we're gonna do red. There's 3, and we're picking all 3. The not red blocks. There's 7 of them, but I need to pick how many total. 1 of them, right? Because I already picked 3 to make 4 total. How many blocks do we have total? Total is 10. No. Yeah, 10 total blocks, and we're picking 4 of them. There we go. Oh, instructor cheat, where are you? I wouldn't use that on a test. No way. Instructor cheat. Ugh. Okay, I probably would. Ah, fraction. There we go. 1 out of 30. Just give me a whole second. I know we got like 4 minutes. We got 4 minutes still, right? Ah, the swimmer problem. Ugh. It's okay. We got this. Okay, so total of 15 swimmers, and we're doing 3 swimmers, and 2 of them want to finish first and second. Okay, so is order important for races and swimmers? Yes. So NPR, is this the amount of folks that are moving around? Okay, I know the bottom. Everyone knows the bottom, right? It's 15. 15 swimmers are in there. Okay, I don't know the bottom. Oh my gosh. This is why we're reviewing, because I don't know. I'm going to go 15-15. And then I'm going to do, in the top, we have 13-13. Am I wrong? No. Is it like 3-3-3? No, no. Is it? I think it's 1313. Simplified fraction. All right, I'm totally wrong. Yep. What did I do wrong? Just give it to me. Give it to me. You can get it wrong. It don't matter what they do. The 6. Okay, I remember now. This is totally fine. Everything we did was fine. But then we could get, I think it's NPR now again, 3-3. Okay, so yeah, that was a cat symbol, but I'm sorry. What the hey, Chad? Well, we talked about this a bazillion times, and okay, I'm going to be very liberal with my grading because I can't do it. But it's okay. That's 6. I'm saying that there's 3 swimmers from that school, and they're all 3 swimming, I think. And then who can I move around, and then the total, and we're done. I'm done. I'm done. I already got the confetti. I don't have to do this anymore, do I? Okay, but again, I'm just reminding you, I'm not perfect. I'm going to grade it very liberally on this one. Go through as many as you can, but again, don't say like, "Oh man, I'm totally going to fail," because you won't. Not over this, okay? Not over this. Give it an effort. Don't leave it blank. Blank, I can't help you. Put something in there. Does that make sense? Okay, good. I'm being recorded. Huh? Find the exam. Yes, let's talk about that. So in Newton, or I'm sorry, in Blackboard, we go scroll down and it'll be right there, exam. And so when you go down to the math lab, you pull up Blackboard, you go here, you click, and they're going to say, oh, you have to launch it. And then they got the password and all that kind of stuff. They type it in for you, you're good to go. Cool? Awesome. All right. That's it. I'm done recording. Thank you, guys. See y'all later. We can talk more about this next time if you want. You just let me know, okay? I don't mind talking about it again next time.